Pre-Calculus, Unit P, Section 7, Equations. In this section, we're going to review solving equations, all types of equations: linear, absolute value, quadratic, rational, radical, absolute value. I think I said that. Anyway, the first thing you want to develop is how to look at an equation and recognize what type it is. We're going to start with solving linear equations. A linear equation will just have a single variable, in this case x, or sometimes two variables, x and y, both to the first power. What you're going to do always, in general, is to isolate the variable on one side of the equal sign and numbers on the other. And you do that by undoing the math. So right now, we just need to get x out of these parentheses. So you're going to distribute your 4 and your 3. Then we want to combine variables on one side of the equal sign, so we get 2x, and numbers on the other will equal 10. Then you're going to undo the math that's happening to x by dividing by 2, so x equals 5. What's nice about equations is you can always check your answers. So plug in your potential answer into the original equation for x. And then just do the math. So on the left side of the equal sign, we get 4 times 11, and on the right side, we get 29 plus 15. So the left side is 44, and the right side is also 44. This is a correct check statement, meaning that your solution is correct because the left side will match the right side. This is still a linear equation, but it involves fractions. So a really good method to use is to look at the denominators of all three of the fractions and find a common denominator. So we're looking for the smallest number that 4, 14, and 7 will divide into. So a little technique is to take your largest number, in this case 14, and do multiples of that number. So if we take 14 times 2, we get 28. Right away we can see that 28 is our least common denominator because it's the number that both 4, 14, and 7 will divide into. So now what we're going to do, it's a technique called clearing the denominator. We're going to multiply every part of this equation, so both expressions on the left and the right side, times that common denominator over 1. So times 28 over 1. So our first expression, the 4's divide out, and we're left with 7 times x minus 3. Our second one, the 14's divide out, and we're left with 2 times 5 or 10, and then the 7 divides out, and we're left with 4 times x plus 5. Now this is just a simple linear equation, so we'll just get those x's out of the parentheses, and then put variables on one side and numbers on the other. So 11x will equal, when we add our 21 to both sides, 11, or x equals 1. Now let's check this solution. We're going to plug in 1 for x in all places where it occurs in our given equation. So on the left side of the equal sign, we get negative 2/4. On the right side, we get 5/14 minus 6/7. So negative 1/2 equals 5/14 minus 12/14, or negative 7/14, which reduces to negative 1/2. So that checks because we get a true statement. The left side equals the right side. In this example, we're going to solve rational equations. So when we solve the equation we just did, we were solving a linear equation, but it had constants in the denominators for the fractions. A rational equation includes at least one variable in the denominator. So for our next example, we're going to solve this rational equation. So what we're going to do is get a common denominator, but first I want to go and factor any of my denominators, and I see that the one on the right side of the equal sign will factor for me. So two numbers that multiply to give me negative 6 and combine to give me positive 1 are 3 and negative 2. Now we can build our common denominator. So remember, we start with the denominator on the left, and then we're just going to work left to right. So we have the expression x plus 3, and then we need to add x minus 2. And then it takes care of our denominator all the way on the right side of the equal sign. So this is our common denominator. Now we're going to use a technique like we did just a moment ago, where we multiply each part of this equation by this common denominator over 1. When we do that, this technique is called clearing the denominator. This may be a little different from the method that you learned in Algebra 2 to solve rational equations. It's very efficient. So when we take our common denominator times our first expression, the x plus 3's divide out and we're left with 6 times x minus 2. And the next, the x minus 2 divides out and we're left with 5 times x plus 3. And then finally, both divide out and we're left with a negative 20. Now we have a simple linear equation that we can solve, just like we have in our earlier examples. So x will equal 7. And then I can put that back in and see that that will check. I also, with rational equations, what I'm really looking for is if I plug that in for x in any of my expressions, that I do not get 0 in my denominator. Sometimes you'll need to solve a formula for an indicated variable. We call this rewriting. So we rewrite the formula so that the variable that's indicated is isolated on one side of the equation and everything else is on the other. So we have this formula. Who knows what it means, but we're going to solve for q. That's just the indicated variable. So since I have fractions, I'm going to find a least common denominator and use my technique to clear those denominators, multiply by that common denominator over 1. So my common denominator is p and q and f, p times q times f. So I take all parts of that equation and I multiply by pqf over 1. So in my first expression, the p's divide out and I'm left with qf. Then my q divides out and I'm left with pf, and my f divides out and I'm left with pq. Now I need to solve for q, so what I need to do is gather all my terms that have q on one side of the equal sign and my terms that don't on the other. So first I start out incorrectly. Then I realize that that's what I need to do. So I'm going to move all the terms with q onto the left side of the equal sign and the term without the q on the right. Now what I can do is I can factor out that q. This is what I have to do in order to get that q isolated. And then finally I can divide both sides by the entire expression f minus p. And that's how I have solved for q. So this is a very important step here. If you're solving for a variable that is in multiple expressions in your equation, gather those expressions on one side of the equal sign and then factor that variable out. Then you can divide both sides by what is left. The absolute value of x describes the distance that x is from 0 on a number line, and x just stands for some number. So we can have numbers that go in both the positive and the negative direction on a number line. To solve an absolute value, we think about that definition and rewrite the equation without the absolute value bars, where 1 equals a positive expression and 1 equals a negative, because we know that on a number line you can travel in both of those directions, so the distance could be in either direction. So for this equation, first thing we need to do always is to isolate that absolute value expression. So we're going to undo the math. So I'm going to add my 20 and then divide by 4. Now my equation is the distance equals 5 away from something. So that means it can be 5 in the positive or the negative direction. So we drop the absolute value bars and we set up one equation where it equals that positive value of 5 and one equation that equals the negative value of 5. And then we solve and we'll find both values that will give us this distance in either direction. It's always good to check with absolute value to make sure. So we're going to plug in first -2 for x. So that'll give us in the absolute value 1 plus 4, or 4 times the absolute value of 5, which is 20 minus 20 does equal 0. And then plugging in 3, we get 4 times the absolute value of -5, which is positive 5 or 20, and then 20 minus 20 equals 0 again. Now we're going to talk about solving quadratic equations. So in the past, you have learned different methods. There's 3 main methods that you can use to solve quadratic equations. You can't use every method with every equation. Basically, you just have to use process of elimination. It's always good to see if a quadratic equation will factor. So if you have to, you rewrite the equation so it's on one side of the equal sign equal to 0. Then you're going to factor it using methods you've learned prior. You're going to set each factor equal to 0 and solve. So first of all, let's set this equal to 0 by subtracting the 1 over. So now let's see if it'll factor. I'm looking for 2 numbers that are, if multiplied, will equal a times c, and that if combined will equal 1. And so 2 and -1 do that. So because I have an a value of 2, and my a value, my number in front of the x squared term is not 1, I need to factor by grouping. So I'm going to rewrite the middle term using my numbers 2 and -1. Now I'm going to group the first 2 terms together, and I'm going to factor out greatest common factor from my first two terms, which is x, 2x, and then my second 2 terms, which is -1. Now I factor out that common expression of x plus 1, and I put what's left in my second expression. So now I have the factors that if I multiply those together, I get the original equation. To find my answers, I set those each equal to 0 using the zero product property rule. So x equals -1/2 and -1, and x equals +1/2. Sometimes quadratic expressions will not factor, and they simply have just a squared term, like an x squared term. In general, we call that a u squared term. In that case, we can simply take the square root of both sides. We have to recognize that when you take a square root, you can get a positive or a negative. And so that will give us our 2 possible solutions for quadratics. So example 7 is this problem. Notice there's only an x squared term, so let's just isolate that on one side. So we'll add our 21 over and divide by 3. So x squared equals 7. And then I'm going to take the square root of both sides. I know that a square root can be positive or negative. So x will equal plus or minus the square root of 7. We can write this in set notation, showing that it can equal negative square root of 7 or positive square root of 7, or we can also write it as plus or minus the square root of 7. And then finally, you can solve any quadratic by using the quadratic formula. So we have to put it in standard form so that we can pick out our constants of a, b, and c, which I have done there. And then we'll take those values and plug them in for a, b, and c into our formula. So x will equal -2 plus or minus the square root of 2 squared minus 4 times 2 times -1, all over 2 divided by 2. So -2 plus or minus, do what's underneath that, which will be positive 12 all over 4. Then simplify your square root. So the square root of 12 will simplify to 2 times the square root of 3. And then finally, divide out terms if you can. So I can divide both the -2, the plus or minus 2, and the 4 by 2. So our final answers are -1 plus or minus the square root of 3 over 2. Finally, a radical equation is an equation in which the variable occurs in a square root, cube root, or any higher root. We solve them by raising equations to the nth roots. We raise both equations to the nth power. Equations with nth roots, we raise them to that power, the nth power. So if necessary, we arrange terms so one radical is isolated on one side of the equation. raise both sides to the nth power, solve the resulting equation, and then check these solutions. So let's isolate this radical by subtracting our 3. Now this is a second root, so we're going to raise both sides to the second power. So nth roots get raised to the nth power. So we get x plus 3 equals x squared minus 6x plus 9. Now I notice I have a quadratic. Well, I know how to solve quadratics. I'm going to get it in standard form and see if it factors, which it does. Two numbers that I'll multiply to give me 6 and combine to give me -7 are -6 and 1. So now I can set each of those factors equal to 0 and solve. And so my two solutions are 1 and 6. If I check those, if I plug in 1, I get the positive square root of 4, which is 2. 2 plus 3 equals 1. So it doesn't appear actually that our solution of 1 will work. If I plug in 6, 6 plus 3 is 9. Square root of 9 is 3. 3 plus 3 is 6, and that does equal 6. So we always want to check our solutions to radical equations. So that concludes our notes on solving all types of equations. Make sure that you've gotten down all the important notes that you need.